This is a little video on how to solve systems of equations with elimination, but this video is really focused on when the elimination is not an easy process to do. As you can see, we are kind of aiming for having everything in this standard form here, where the x and the y are on the same side and that constant's on the other side. That's not true for either of these, so it's kind of a pain in the butt, so we have a little bit of work to do first. The first thing that I did here in orange was just say, hey, well, the x and the y are at least on the same side. They would just need to be switched, which I can do if I keep the coefficients. I also can switch two sides of an equal sign, which I did. So I didn't do any math there. I just used my rules of general properties of being able to switch numbers around in between equal signs. I took the second one, which was a little more work. The students last hour noticed that, hey, that constant's on the wrong side, so they moved that. If we're going to move it across the equal sign, then we have to do the opposite. Then they noticed, oh, hey, well, the x is on the wrong side too, so they canceled that, and now we have two new equations. In green there, you can hardly see because it's reflecting a little bit. I have too many windows in this room. What a problem. So then we wrote them together, but then we realized, hey, there's another problem. The other problem is that the coefficients don't match. So they decided that they were going to multiply everything in the bottom by 2. If one person gets a cookie, everybody gets a cookie. This other equation does not need to be touched though. So we're going to multiply everything in an equation, but the other equation can stay alone, be left alone. After we did that, we put the two equations together. They decided to add last hour because our signs were opposite. So we took -7 plus -4, -20 plus 20, -14 plus -8. And a lot of things canceled out really beautifully, and we got an answer of 2. A really important question that came up last hour also is, hey, what do I plug that 2 into? Do I plug that 2 right into this x right here? Always, 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 always plug it back into one of the original problems. First of all, they're usually smaller, but more importantly, they're automatically correct. You could have made a lot of mistakes. This whole board is filled with places for error, but the original equation won't have that error. So when we plugged it in, instead of writing the x, we put in the 2 and we're multiplying because they were written next to each other. We found out that y was 0. And we're writing our answer as a coordinate point every time. Please feel free to pause this video at any time, watch it, rewatch it, look for clues and look for things that we're looking for to solve all the time. Thanks.